Alright, let's get started. Another stream towards making a Pokemon Nuzlocke beating AI. Where we left off last time, we had something that could beat the first gym. And this was before we even introduced reinforcement learning or any other real AI approach to solving the battles. Instead, we just used a very simple choose the best move AI that just chooses the highest power move based off of your typing and the opponent's typing. It doesn't ever try to switch. It doesn't ever try to do anything complicated. That's our so-called best move player. Very simple, and it is not really equipped to deal with all of the challenges that could possibly be in a game. So instead, we'll want to improve it by making it even better. And there's two different ways of doing that. There is improving the team building component, that the AI needs to choose the right team for the right fight in order to be best equipped to defeat it. And there's the battling AI, where it needs to be able to actually perform a battle well, given the opponent and its stats and you and your stats and all of your switches. It needs to be able to do the right thing at the right time to win the battle with as few losses as possible. Everything was working in our framework at the end of last time, and we were able to get through the first gym. I've since added details up to the second gym in our Excel spreadsheet that is managing the run. So in theory, we'll be able to test things up to Gym 2 now. But with Gym 2 comes some extra features that we need to add support for. Namely, two very large things: items and double battles. Items are now available because before the first gym there really isn't any item that you can easily get. But after the first gym there starts to be a lot more held items that you can give to Pokemon, and we need to be able to add support for the AI to choose those items and give them to Pokemon. As well as knowing if the items were used up, and if they were used up to discard them, and if they weren't used to keep them. Additionally, double battles. There are, I believe, 2 double battles before Gym 2, in between the 2 gyms. So we will have to, if we want to have an AI beat the first 2 gyms, we will have to have it support double battles, not just single battles. Additionally, later in Pokemon Black, we'll expand upon this because there are actually triple battles and rotation battles, which are an extra added gimmick inside of Gen 5. I'm not sure if Showdown has support for these types of battles. If Showdown doesn't have support, then we'll figure that out whenever we come to it. Right now, we've written everything in such a way that it can run on any game. So if it gets to the point where we would have to build something into Showdown to support it, then we might just either switch games and do a game that doesn't have rotation / triple battles, or just kind of skip over one battle, or just treat it like a single battle for the purpose of preparing. Because really, functionally, in a rotation battle, you could act like it's a single battle, and I believe that Showdown has done triple battles before. So we'll have to see whenever it comes to it. Other than that, I've found out how to add custom battle modes into Showdown that aren't the current popular ones. So I was able to add in this Gen 5 Pure Hackmons and Gen 5 Anything Goes. The point of the Pure Hackmons is that I wanted to simulate hundreds of thousands of Pokemon battles with kind of randomized teams. And I didn't want to have to deal with making sure every team was perfectly legal, because in Anything Goes, if you have an evolved Pokemon that's a lower level than it's supposed to be, then it could technically not be a legal Pokemon, and other things like that. So there's 2 modes. There's Gen 5 Anything Goes, which is for completely legit stuff, and this is what the actual run will be using, is Gen 5 Anything Goes, because we must enforce that everything is legitimate. Anything Goes just means your team can be whatever you want, but every Pokemon has to be legit. And then Gen 5 Pure Hackmons has all of the Gen 5 mechanics, but your Pokemon can be whatever. They can have whatever hacked ability or moveset or anything, be any level. So this is good for simulating things. So we'll be using these 2 modes down here at the bottom. I might disable all these other modes just so that whenever we load in the screen, it's just much more simple. But I've actually been running lots and lots of simulated battles since last Thursday. I've been running many rounds of simulated battles. As part of this stream, I might work on improving the code that does that a little bit, because right now it's not the most efficient code. I think because it's a little bit like single thread limited. But if we can improve this code that is doing simulated battles, we can have more and more results faster. Right now, I have in an Excel spreadsheet all of our simulated battles, and I've been computing two different measures. Right now, we have the this top chart is the original Elo. So this, I created 100,000 randomly generated teams out of all of the Pokemon in Pokemon Black and White that you can get. This is because Pokemon Black and White, they use their own Pokédex with no overlap between previous generations. So it's another like 150 or so Pokemon that then I can simulate battles between. So each team is a random size between 1 and 6. And then let me just make these charts even bigger so they're a little bit more visible. Just want to move this over. Okay, I have to move this one first. There we go. So there's the original Elo, which this is the Elo according to Pokémon Showdown of each simulated team. And then this is like kind of an adjusted Elo that I'm trying to do, because unfortunately Pokemon Showdown, in order to not discourage people who are playing, they have a minimum Elo of 1,000. This isn't very good because you also start with an Elo of 1,000, which means you have a very large amount of people. In fact, the single largest bin in this histogram is people who are at 1,000. And nobody has a lower score. So this means it's very hard to compare between bad teams, because two bad teams will basically have the same score because they'll both be at 1,000. But one could be twice as bad as the other. So this adjusted Elo, what it does is it takes into account this original Elo, but tries to factor in the win-loss ratio of the team. So that way, if it's a team that has lost 142 times. Oh, let me zoom in. If it's a team that's lost 142 times, then it's probably worse than a team that has only lost 90 times. And it's probably worse than a team that has won once and lost 131 times. Maybe not by that much. You can see the adjusted Elo is like 13 and around there. But it's it helps make the score just a little bit more reasonable. Let me fix this round function so everything's a nice whole number. So there we go. Now we've got a whole number integer Elo, which will be the score of our Pokemon. And so the idea is that what we'll do is we will create some sort of model that takes in the team associated with this team. So team 49,036, and tries to predict what the adjusted Elo is. Now I'm running battles constantly. It's just in an infinite loop of simulating battles. I've been trying to optimize it because right now a lot of battles are getting timed out. So I'm trying to find some ways of optimizing it and find what the bottleneck is so we can improve the rate that it is simulating battles at. In theory, the way it should be running, if nobody's timing out, it should be doing about 30 battles per second. But lots of battles are timing out because of some connectivity issue. So that will be another thing to try to solve tonight to get it just working smoother and everything steadying out in a faster way. So that's one thing that we need to do. Another thing is also add in support for items and double battles. So 3 different things. I think probably the first thing, Elo, I think it might actually just be a name of somebody, because I believe it's named after a person. If we look up Elo, not Electric Light Orchestra, I believe it's named after the person who came up with it, and it's originally for like chess. So people talk about like their chess rating. But other games like any like MMR system in a video game also uses it pretty much. So it's kind of how your rating system is, and the idea is that if you have your Elo and you have an opponent's Elo, you can plug it into an equation and it will tell you what are the odds you should win. And if you do better than that expected odds, then your points increase by some certain amount. And if you do worse than that certain expectation, then your points will decrease by a certain amount. That's kind of vague, but the equation, if I show it, is a little bit involved. This is the equation. We can just basically plug in the numbers, and actually Showdown just handles it all for us. This is kind of telling us how good is a team. So our idea is we can take the Pokemon that are involved in this team with their details, their moves, their abilities, everything else, and we can try to create a model that, given a team of Pokemon with their moves, it will try to predict this adjusted Elo. So then, whenever the AI is at the team building phase, it will try to predict what is the best combination of Pokemon to have the highest Elo. And this Elo will kind of be a score of how good a team is. It's not a perfect measurement, but it is good enough. And so constantly in the background, we are simulating hundreds of thousands of battles. So far, if we check, just by summing up all of the wins that have happened, we can see that there have been 759,000 battles. But the theoretical maximum rate that we should be doing battles at is about 30 battles per second. So that should have been done in like 6 hours, but this has been running over a couple of days. It's just because the code is really inefficient for running the battles, and lots of battles are timing out. Probably because I'm running this all on one machine while I'm doing other things. So there's some bottleneck somewhere. So part of it will be trying to find and remove that bottleneck. So that we can simulate battles faster, teams kind of steady their Elo. I would like to see this kind of not change too much. Once it kind of, everybody's kind of battled everybody a lot, the numbers in theory shouldn't change too much. But then that'll help provide training data. And this will be, since there's about 100,000 teams, this will be 100,000 data points that we can feed to some sort of neural network. Or even just a simple model. You can calculate the conditional probabilities and have a model that builds teams. Or have a model that predicts how good a team is, and then you can try to find what's the best value to plug in, if that makes sense. So pulling up the code, this is our code for doing this ladder approach. Basically what's going on, right now I've just kind of hard-coded a list of valid Pokemon to use. It'll just randomly pick up to 6 Pokemon. They're all set to level 80, so that right now it's not trying to predict how good is being a level, because obviously higher levels is always better. So there's nothing to be gained from trying to study the effect of levels. It will build a random team based off of the possible Pokemon, the random seed that it's given, which is just for reproducing it. So the same team always gets the same, or the same team ID always leads to exactly the same team. That way, if I stop and start the code, I don't have to worry about the IDs being assigned different teams. And then a cache, just because I'm pulling some information from an API. So basically, it builds a random team with all the information, all random abilities, random moves, that are all technically valid, but maybe not necessarily legal in a real game. so it might know the wrong moves at the wrong time. Random stats that are valid builds like a showdown team that then is battling others in Pokemon Showdown. This is a locally hosted Pokemon Showdown. That way I can spam it with as many requests as I want, and I won't get timed out. Because if I were trying to do this on the real Pokemon Showdown, I would probably get IP banned, and it would stop there. So I'm running it locally. Luckily, it's open source, so it's really easy. And then I'm doing something that's challenging the ladder. So basically, I'm running this function, challenge ladder, over and over again, all at the same time, with a bunch of players. I'm doing about 1,000 players at once. So it's almost like there are 100,000 registered users, but only about 1,000 log in at the same time and play each other. And it's a random 1,000. This is because I can't have everybody play everybody at the same time. It just leads to too many timeout issues. So the next thing I'm doing is trying to figure out how can I make this faster, because I did do something where it's going to try like to do a battle for 60 seconds. And these AI, when they're going fast, they can do a battle in like 4 seconds. If a single battle takes longer than 60 seconds, I know something's gone wrong. And right now, something is going wrong 73% of the time. So I need to figure that out so it can be more efficient. The battles don't take so long. I think it's because I'm running this all basically on one core. Even though it is like async, so it's like efficient, it's still only running on one core, so there's a limit to how efficient you can do. But yeah, so that's the idea of this whole thing. And also, I don't know if my donations are working yet, but if you just donated, thank you so much for the donation. I really appreciate it. I've started streaming this year, so I don't have that much of a following yet. I only have about like 17 or 18 followers. But thank you so much. I don't think the donation was linked to show up on the screen though, but I really appreciate it. Okay, so where I was thinking I can improve it is because of this single core thing. There is a way of doing that. Like thread, yeah, Python async IO threading. Is something like this. I'm trying to figure out how to do this. So I'm going to create a new file just to kind of test something, or I'll open up a Jupyter notebook to test it. There we go. Let's scroll down here. Okay, so let's copy paste this code. Oop, runtime error. This event loop is already running. Let's restart and run again. I'm not sure what this error message is. Let's try this. This event loop is already running. I'm not sure. Let's look it up. Okay, so I think it's because something is going on with IPython, which is the backend behind Jupyter Notebooks, that it is leading to like it not working. So let's see. If just this Stack Overflow code will have it work. Python async support is not the best, but we're trying to handle it. Yeah, so right now our idea is if we can create a model that predicts the Elo. Like, let's say we have some function like Elo Predictor. Let me zoom in a little bit more so it's a little bit more clear. So we have some sort of Elo Predictor where if you give it a team, it'll give you the Elo. Like right now, let's just say it'll return 1500. All right, so this is technically an Elo predictor. This is a model that predicts the Elo. Well, what we want to do then is we want to build a team that maximizes the Elo that is output. So we will have a bunch of different options. So we'll have a big list of possible Pokemon. Like, you know, that we could have. We could have our starter, a Panpour, I don't know, a Lillipup, whatever. We'll have a bunch of Pokemon that we could choose from. Each of those Pokemon have a bunch of moves that they could know. We could possibly have had a lot of items that we could give to the Pokemon. So what we'll want to do is we'll want to try to find different combinations and run the model and pick the one with the best predicted Elo. So if your possible combinations are relatively small, then you could actually just run the model on every single possible combination. But once you get later in the game, your possible Pokemon will increase. Like, let's say, assume you have like 30 Pokemon by the end of the game, and each of them have like 15 different moves, and that's like 30 by 15. And you have like 100 different items, then, you know, it's like 100 different items that you could put across things, and it just quickly grows. And you have to like choose 6 of them, so it's actually like that many options for your first Pokemon. It's then just like 1 minus that for your second Pokemon. Because you pick one Pokemon and like the number of moves maybe doesn't decrease, but now you have 99 different items, and it just the number of possibilities grows exponentially. So what we'll do instead is we'll probably pick like a random sampling of different teams, score them, find what was the best one there, and then just do small modifications like change just this move to this move, etc. And search again. So rather than searching every possible combination, it'll just pick a random 1,000 combinations, score the best one, and then take that best one and do some slight modifications to try to find the best one there. Like, maybe it'd be better if I show it in a whiteboard. So, you know, we could have originally for the first team, you could have maybe billions of different combinations, but maybe we choose 10,000 completely random teams. We score them using our model. maybe then we select the top 10 teams. Randomly alter them. So not change them completely, but maybe change like up to 5 random things about the team. And then repeat. And maybe repeat until it's relatively steady. Or just repeat 10 times or something like that. So this will give us a team that is hopefully the best team. So we could run it until the predicted elo is no longer increasing. Maybe if the elo stops increasing at a certain point, then we'll just pick the best team that we ever found, predicted by the model. And actually, notably, right now, this is completely independent of what the enemy is. So this does not care about the enemy. This only cares about your own possibilities. So that could be an issue because we might want to take into account what the enemy team is going to be and pick from there. So this optimization is basically a genetic algorithm. So we aren't and we could use an actual already pre-created genetic algorithm to solve this, but it's kind of two different kinds of AI. So the first one is creating this Elo Predictor. So this Elo Predictor is not genetic. So the Elo Predictor itself is trained on the simulated battles. So the input is the team, and the output is the approximate elo, which I'll say is like something like that. And we have simulated 100,000 different teams, all randomly generated teams between 1 and 6 Pokemon. And we have the actual elo, the raw elo according to Pokemon Showdown. And I'm still adjusting this equation because right now it's kind of complicated. But I'm trying to get something that's kind of more of a bell curve than the original elo. Or that has a smooth range of values from 0 to the max, as opposed to this hard limit at 1,000. But the model itself that predicts elo is trained as like a standard neural network or whatever other model it'll be. Then, once we have this elo predictor, then at runtime, whenever we actually care about building a team, this is kind of like a genetic algorithm. So it'll be random teams. The elo predictor is the score of each team, and then select the top amount of the population, do the random mutation, and repeat. There are libraries that handle this process for you. We don't necessarily need this to run perfectly or run to find the actual optimal team. Because otherwise you're basically running a genetic algorithm, training it start to finish every single time you want to build a team, which might mean that to build a team, it'll take like 20 minutes every single time you run it. So it depends on the runtime and how many iterations and what this kind of space looks like. Especially since our mutations that we can do are actually constrained, because you can't pick a Pokemon that you don't own. It has to be a Pokemon you own. But yeah, hopefully that makes sense. And this is our data set that's still getting built, actually. And this is we can like even update this data. It takes like a couple of minutes to update for whatever reason. I don't know why Excel is so slow about updating it. But it's linked to the actual kind of logs of our battle simulated. So we can see like what's the current #1 team and what's the worst team. And also the reason why we have to do this adjusted elo, divide by 0. Okay, something's going wrong with the format, but yeah. Some of these have 11,000 elo. Yeah, something broke with the update script. I'm gonna close it without saving, so it doesn't brick it entirely. I think it's because the output file is getting written to so much. Normally I pause it whenever I refresh it, but basically it's our current simulated elo, and there are thousands of battles ongoing right now. Like if we go to watch a battle, we can see there's tons of battles going on right now that are being simulated. Oh, this was a timeout battle. Yeah, this is a part of our issue right now, is that the code that is simulating all of these battles is leading to a lot of timeouts because there's some bottleneck somewhere. I believe it's in the threading of the asynchronous calling. That I think it's too much for one CPU to handle, and it's leading to problems. So I'm trying to figure out where is it going wrong. Let's see. Sleep time. Took one. Okay, so this is waiting for a certain amount of seconds to run. CPU bound operation, but where are they doing the multi-threading? So our issue is that this is my theory. My theory of the issue is that all of these battles, it is asynchronous, which is efficient, which means that while one task is waiting, the CPU can be used for something else. But I think it's all running on a single core. So basically that core is constantly busy, and it means that lots of tasks aren't ever getting started. So ideally we would actually be having multiple cores working on the battles all at once, because we're actually using 8 cores for the Pokemon Showdown server, so I can use a lot of cores for this too. The machine that I'm on right now, it has a Threadripper 3960, which has 24 cores, which is like 48 threads of headspace, and so with a couple of threads for the streaming and a couple of threads for just general performance, we should have a lot more multi-thread performance to use. In fact, right now, if we look, we can see that our CPU is only 30% used right now, or even less. Like lots of threads have lots of space to be used. Also, our memory, we're at 92 gigs of usage, but we could scale that up a lot more. So we've got plenty of headspace for this computer to actually be used more for Pokemon simulating, but we're not taking advantage of that, and I think that's part of our bottleneck, is that I think our main thing is more CPU limited in the simulating. Yeah, I've spent way too much money on this machine over the pandemic. This was kind of my bad pandemic hobby. But let's see, Windows command processor. This is the Pokemon Showdown server, which is actually multi-threaded and is going okay. But then there should be another server, another command prompt. Maybe it's this Python one that we can see is just barely using any thread at all. In fact, actually, it might be this one. No, that's one Docker thing. Yeah, so the other like simulating thing is barely using a CPU, which if it's 2%, then that's basically 1/50th of the CPU, which is one thread, which would make sense. So if it's just hammering one thread, then it should be at about 2% usage. Meanwhile, Pokemon Showdown, on the other hand, is using a lot of the CPU. It's using 12%, and 12% of 48, 12 times 48. It's using about 6 cores worth of performance, which I gave it 8. So it's not even fully using its cores. So that's, I think, the issue is in this kind of not making the most of the resources. As for how to improve that is the question. I'm thinking it has something to do with this like kind of pool executor idea, but I'm not the most sure about how to get that working. I just had a tab open that had it. Ah, was this it? Yep. Module object is not callable. Yeah, I'm getting weird errors about like event loops already existing. Hmm. We've got to figure out how to add it. Okay, so something about their example code isn't correct. That's good. This Python asynchronous stuff is not the most fun thing in the world. This is not like every article that I find when I'm looking this stuff up is just like, oh, how to use async IO instead of multiprocessing. But if I want to use both, then what do I do? And everything that I find is like not modern, or it doesn't work anymore. Because like this is from 2015, but then whenever I put the code in, it stops working because it says it no longer works that way, which is just awesome. Like here, it's like saying, oh, you can't do yield from inside of an async function. It's just It's like, well, that's exactly what they do. So I have to copy this somehow. Yeah, thanks. Ooh, AIO processing. Yeah, I'll be here for probably another 4 hours. 4 hours, 15 minutes or so. I stream until about midnight my time, and it's almost 8 o'clock. So stop by if you want. Yeah, it's after hours here in Japan, so. Alright, we can try this library. This library looks like it might work, but it doesn't seem like it, doesn't seem like it'll actually be multi-threaded, though. Okay, let's try this. Let's try this approach. Okay, let's try this and see how it works. Git install AIO multi-process. Okay. Pool is closed. That's fine. Process pools. Is this supposed to be await? Doesn't seem like it. Okay, let's try an even simpler example. Name error. Math is not defined. Really? Weird. We're getting even slower. I'm gonna go ahead and stop our simulators and see if that's contributing to the problem. Because this is just incredibly slow. I don't know why it's taking so long. Okay, that's taking forever. So, you know what? One last time, I'm just gonna try copying a different example. And if it still doesn't work, then I don't know what I'll do. This get is just gonna be something that says sleep for 5 seconds. I'm gonna pass in no functions. Mm-mm. Is it a Jupyter Notebook issue? Ooh, we got a big error message. Okay. We forgot the if name equals main. Worker is not defined. Okay, that's a new error message. That's better than what we were getting earlier. Oh, oops. None type has no attribute start. Hmm. Two, three, four, 5. Okay, so that took 5 seconds to run, which is what we expect. Now let's look at their pool example. Start is equal to time, print, string, took, time, minus start, seconds. One, two, three. Oh, coroutine get was never awaited. Two, three, four, five. Too many values to a pack. Expected 3. Oh, because these don't return anything. One, two, three, 4, 5, 6, 7, 8. Okay, so it took 6 seconds to run 10 of them. Let's see if we limit it processes. What? How is it spelled? With the default, it will create enough for each CPU core. Okay, well at least now we have a pool. What happens if we try to tell it to do 10,000 of them? Keep clicking on them. I'm going to close the Jupyter Notebook. Okay, so now it's doing 10,000 different sleep for 5-second things, and we'll see how long it takes for the whole thing to run. The whole thing took only 6.2 seconds, despite the fact that it called 10,000 things that involve sleeping for 5 seconds. So I think this definitely was the way to go, which is great, because that means I don't have to change really anything except for put this around the gather. That's really good. Basically, instead of calling async io.gather, I have to just say... Oh yeah, no, I just still say async io.gather. Wait. Is it even using the pool? How do I know if it's using the pool? Process pools. Pool.apply. I'm not even using the pool. Pool dot. Okay, well, that was dumb of me. Pool.apply. 2, 3, 4, 5, 6. And now it's taking much longer. Ugh. Come on, really? I was so excited for a second. I thought I finally cracked it and it was gonna work. But I don't think it worked. Because it's taking significantly longer. Really? You know, let's get rid of that other await. Maybe that's because that's not in their example. So maybe it's the other await. Nope. All right, let's. .11 seconds. Yeah, the pool is even slower than just doing it normal async. Which doesn't really make much sense to me. Well, if that's the case, then we can still try it and see if it's any faster, but we're not too hopeful. There is still an async function, right? Just to make sure I'm covering all my bases. Yeah, it's still an async def function. Huh. That's real annoying. Well, let's try it. Pool.map or pool.apply. No, we can do pool.map. Instead of async.gather. Because that's what they did here. And if we look at process pools, Okay. Alright, let's try this out then. So it's going to be await pool.starMap challenge ladder on there we go. All right, let's see if this is any faster. We can pull up this. We just have to run ladder run.py. Oh, it's gonna say pool is not defined. Let's try that again. Right now, this is the generating all of the teams part. So it's creating 100,000 teams. It's using a random seed, so it is repeatable. So we can start and stop it over and over again, and it'll be exactly the same each time. But it takes about a minute, typically, to load all of the teams. And then we'll see if our optimization is working. From our initial results, it seems to be slower on the test case, but maybe it'll be faster on the case where there's more CPU involvement rather than sleep, because the sleep case was very asynchronous because it's just waiting, so it has to do no effort. But this actually has some effort, so I wonder if it'll be faster. We'll have to evaluate it. The time to beat is about 100 seconds for the like one round of battles. So after this runs, it'll start running round after round of battles between all of the opponents. If it's faster than 100 seconds, then we'll know that we've done something right. If it's slower, then we're kind of back to the drawing board. Like, what we might have to do is kind of go full parallel processing, where we are just multiple instances, where each one kind of gets a carved out piece of the pie, and it picks a rank. Like, maybe we have 5 scripts running at the same time. Each one gets 20,000 players, and it selects from those 20,000 a random 200. A random 400 players. That way, they're all completely separate instances. They have nothing to do with each other. And so in theory, they can be all on separate cores. Then we don't even have to worry about doing the multiprocessing within one single script. It'll just be multiprocessing by the fact we're running it in 5 different windows. So that could be one idea that improves it. But we'll see, based off of the results of this, if it's worth it. Or not. It's starting round 1. Let's open up Pokémon Showdown just to see what's going on. Yeah, there's 3 battles. Oh. No. Let's see how many battles are actually ongoing right now. There's 100 plus battles going on. So at least it is simulating battles, which is good. There's more than 100 battles going on. What about 1,300 plus battles? There's only one battle that's 1,300 plus. I wish I could see how many total battles were going on at once, and it didn't just say 100 plus. Oh, they left because it timed out. So I think maybe we need to set our timeout to larger or something. But really, they should be making their moves faster too. Because they just left. The players left probably because of timeout issue. And when they both leave, it's not even considered a draw. Yeah, and here they both left too. So these battles aren't getting finished for some reason. There's some inefficiency happening where the battles aren't getting finished. I guess that is something we could do. We could run this in 5 different things and see if it helps. But they would need to be timed at the same time, generally. Oh, actually, so it was slower, but actually fewer finished to timeout. Earlier we were getting around 70% failing due to timeouts. But this is actually better. Like, it took longer, sure, but this is a better percentage. So maybe this plus doing it fewer. Like, if I were to just simulate the workload by doing 200, would it be that much faster? So the idea is that we have 5 different scripts running to each take on 10,000 or 20,000 people, randomly selecting 200 of them and having them battle. Since they'd all be using the same server, they'd all be potentially able to battle each other. And so maybe that would help. But we need to find out where our bottleneck is. Because if we want to simulate millions of battles, the current pace it's going at is going to take weeks to simulate that many battles. But in theory, we should be able to simulate, like, the fastest that I've gotten battles going was like in concurrent processing was 30 per second, which is a very, very large amount of battles. Alright, let's see. So this is going to do 200 battlers at the same time. And we'll see how much faster it is. So the pool method led to timeouts less, but it took longer. But that might be okay, because we want people to finish the battles. Let's see if this also leads to fewer timeouts as well. Let's check Showdown. Oh, this is a battle from earlier. See, they're making moves fairly fast. Oh, ladder matches were a complete success for 100% of competitors. So that time, 100% finished. It took about a minute to run, and nobody was cut short. So I think this is the way to go. because everybody got to finish. The only question is, like, when does that start becoming an issue? Like, if we say 400, which is now twice as many, will this work? So now twice as many battlers. And these are all abandoned fights. These ones here. These 87 fights. On the bright side, the startup speed will also be faster if we split it in 5, because we don't have to generate all of the teams. We can just generate only the teams that we need for that worker thread. Okay, so 200 battles took 62 seconds, but with perfect finish rate. Let's see what 400 battles at the same time on one thread does. We can see there's like hang time where they're waiting for the players. But that battle is a success for one of them. So that battle finished. Also, each round is 2 battles. It's one player goes, then the other player goes. Or sorry, it's 2 battles. I don't know why I said one player goes, then the other player goes. That doesn't make any sense. It's like 2 rounds for each player. So each player gets to fight in the ladder twice, and then it stops. I used to have a much larger amount of ladders, but I found that that was one of the ways to try to make it more efficient. And also I wanted to have as many players get the chance to play as possible. So I figured it's better to do more rounds rather than each round being more fights. So hopefully that helps. All right, and now when we bump up to 400 workers on a single thread, now it's cut short for 24% of competitors. So it's too much work for one thread to do. And I think if we just switch it back to, again, this gather thing, it'll be the same story. Async io.gather. Just to verify, we're going to repeat this same experiment again. It was 96 seconds with 24%. So we want to see, where is it better? Is it faster but less successful? Is it better than both? Whichever. But because we ideally we would want to be simulating as many battles at once in order to increase the most likelihood for like the best of the best to fight each other, increase the most likelihood for like a range of players to battle each other, and also just the more battles that go at once, the faster it goes. So ideally, you know, if everything were working smoothly, you could have everybody battle at the same time. But clearly we're resource limited. So I'm going to go ahead and open up several more windows in the background. This is basically the inefficient way of doing parallel processing, which is just literally running it multiple times, but with like a command line argument. Okay, that's 3 new windows, and then I'm going to open up a 4th new window. Okay, so I have 4 windows standing by to run multiple threads in it. I'm going to have to add a command line argument to tell it which teams each command prompt is responsible for. But the last thing to do before we actually start doing that is just see which was the more efficient way, doing the standard async or this pool method. I think it was that the pool was slower but led to less timeouts. But this is the best way of measuring it, is just running it and see what kind of results we're getting. Because ideally we don't want any timeouts. Yeah, we can see there's lots of times where it's waiting for players. And that means that the CPU is being used too much because the AI isn't immediately responding. If you were just running one battle at a time, the AI would like immediately respond. You wouldn't even notice the waiting. Okay, yeah, so this team won again, and it won by a decent amount. Still going. Alright, so basically the same amount of timeouts, and actually basically the same amount of time. So I think basically the pool.map didn't matter, so we'll just stick with the standard async. Now the last thing is we need to give it a command line argument. Okay, so we need to import sys into main or simulate ladder. We need to be given the worker ID. We need to say worker ID is equal to sys.argv1. This is going to be whatever number we put at the end, because that's how this works. And we're going to pass in the worker ID. And this is going to be a range from 20,000 times worker ID to 20,000 times worker ID plus 1. So it's going to be responsible for some range of teams. And since we're generating everything from a random seed, then that's actually all we have to do. Each one is going to select 200 randomly from its subpool and run them. So now let's just test this. We have 5 workers. We are going to do python ladder run.py 0. Oop. So this is just creating 10,000, and then I'll run Python ladder run.py1 in another window. Python ladder run py2 in another window. Python ladder run .py3. Python ladder run .py4. So there's all 5 of our workers, which each individual worker is just taking 1/5 of the total pie to be simulating. So now if we check out Pokemon Showdown, watch a battle, there's lots of battles going on. And they seem to be slowed again. So they're still having some struggles. But let's look at our performance. If it'll open. Task manager not responding. That's nice. There we go. Our CPU usage in general seems to be doing much better though. Like we're having a lot more CPU usage across the board. So I think just doing the dumb way of opening up 5 more windows and running it makes sense. Oh hey, welcome back. So what we're doing right now is we are simulating lots of battles for the like kind of team building AI to have training data. So far, I've simulated close to 800,000 battles, but I'm trying to make it more efficient so that we can see improvement in that way. Because right now, async processes cut short to 53%. Yeah, so it's a tricky question. Maybe it's because they're not all aligned, but now they're closer, so maybe it'll be better now. We're trying to find out what the bottleneck is, because a lot of the workers are timing out due to, like problems, like they're just not responding. Like, we should never see this waiting for players for such a long amount of time. But we're seeing it for a long time. Which means that the core is busy doing something else. So maybe splitting them smaller even is the way to go. But Windows Command Processor 4. They're using, it seems, about... Oh, they just stopped. Or one of them just stopped. Come on. Just stay still. Yep, they're getting cut short again. Ooh. It is really making my computer sluggish. I'll minimize some of the windows because I think it's really taxing my computer. Hopefully I'm still live because my computer is very, very unresponsive right now. If I run just one, am I still getting the issue? I can look at that to try to see, like, so the main issue is that right now it's hard to tell what is actually causing the problem or where the bottleneck is, because I'm pretty sure it's that running async things in Python is a single-threaded task. But I'm not entirely sure, because then if I run it in a bunch of different windows, I should be able to get better performance, because the tasks have nothing to do with each other. And should, in theory, just run in a random core that's less busy due to the scheduler. But, yeah, I think links are allowed. You should be able to send it. Like, I don't think I set up the filter to prevent links. Okay, so when just one is working, it works and doesn't time out for anybody. Process monitor. Let's just stick this over here. Okay, so I'm gonna move this over to the side for a second. Yeah, so basically, like, when we're running just like one thread at a time, what's being printed out is it's selecting from about 20,000 different players, like teams. It selects a random 200, so like 1% of the teams to be logged on at the same time. Then it has them do ladder battles, so they play against other players. Luckily, because of the way Elo works, if it's just that like hardly anybody's on, so a really strong player gets matched against a really weak player, it won't help them too much. Like, their Elo won't really go up. But ideally we want to have as many players running at the same time. But at about 200 running at the same time, we can see that timeouts only affect like 0 to 1% of our players. So I'm going to start up a second thread now. To see if introducing this slows it down even more. So now that we've got two that will be running, let's pull over this process monitor. So I'm looking over to try to see how to use it. And so players that are in one of them can fight against the other. Yep. I have it open in a separate window. My computer's just being a little bit unresponsive right now. Okay, so let's filter. Yep. Okay, so here's the filter window. Let me hit cancel and pull the whole thing over. I want to pull these up though so I can still see the results. Can I zoom in? I can't really zoom in all that much. Maybe there's a view. There's themes. There's a dark theme, sure. Okay, yeah, and just having something, just having the other one running at the same time leads to a huge drop in time, in the number of successful ones. So there's a bottleneck somewhere. Have you seen one of the processes? I'm not sure if these will appear under Windows Command Processor or what they'll appear under. But we can try like the CMD. Yeah, and it's only getting worse actually. Like the timeouts is only getting worse. Like the timeouts on this one are still not bad. Oh wait, no, they were. I just had it select. Really? Do I have to select the whole C? Let's, okay. Oh, cancel. Add. Okay, so this is one of the ladder runs. This is this ladder run, which they are failing like 40% of the time. Tools process tree. I'll just reset the filters. All right, I hit reset filter and I'll do what you're saying, the tools process tree. Yeah, it's just still, it's still worse. Like this is just getting rid of the filters. It's restoring it back to normal according to what I pushed. Okay. Tools process tree. Okay, so let's scroll through, I guess. Oh, jeez. Stop scrolling. Okay, I see all the Pokemon Showdown stuff. That's all this node stuff. So we can see for the node, this cmd.exe, this is our Pokemon Showdown server. Okay, so I'll include this subtree, because this is our Pokemon Showdown. So maybe we can try to analyze if the Showdown server is our bottleneck. The timeouts are actually only increasing. cut short due to timeouts is now 85%. So it's just getting worse as it runs, which is kind of crazy. Like it's still working. Like technically this isn't causing like a major problem, but it is still it is still not good because it means that it'll take forever to run. Okay, so this is one of the ladder runs, so I'll include this subtree. So we could try to add some extra code somewhere to find like exactly what the breakdown of time is, which might help us. Okay, and then sometimes it works. I'm not sure what's going on because that round it only had 6% timeouts, so it's just really unstable, I guess, is part of the issue. So this is just one, yeah, I think it's going to be really hard to diagnose from this because the asynchronous nature of it is going to split every single await that happens into its own process with its ID, or like its own event that's happening. So it could be very hard to diagnose. Like, at least from this, you can actually kind of see that they're sending and receiving messages back and forth. And I don't doubt that it is talking very hard, like, or talking very fast back and forth. But I think part of the issue is that it's like all of these processes are being like run on the same CPU core. I mean, I can try to check that or something, but it's a mess. And like the crazy thing is just how like inconsistent it is. Like it goes from only 6% of users timing out to 30% of users timing out, so on and so forth. It's just crazy inconsistent. I think it was better when I was running all of them on one core, though. At least it was more consistent. So I'm going to go ahead and go back to doing that. I'll close the other ones that I had opened. And I'll stop this. Get rid of this worker ID thing. And it's just going to go back to going from 0 to 100,000. $200 just seems to be the most that it can really do on one CPU, and I was hoping that by splitting it up into multiple command processors, it would be run on different CPUs and it'd be fine. I've still got it open, it's just minimized. Right click, select columns. Clear the log. Yeah, that would be good. Like, and I guess we have to just try to figure out if it's that there's no events that are long, it's just that it's so full of fast events that it just is maxing out a single core, which I don't think it's actually the case. I don't think it's that it's... Also, it's just not responding anymore. I don't think it's that it's maxing out... Or I think it... I don't know. Maybe it is maxing out a single core, and that I just can't seem to get it to run on multiple cores, and that's the issue. And Python is notorious for having issues about like multi-threading from like a real perspective. So maybe the combination of this asynchronous stuff and multi-threading is just leading to problems. Yeah, process monitor is not really responding anymore. Yeah, I'm gonna force close it. Yeah. Okay, and so running just a single one led to a success for 100%. So this, if we just leave it to run for a long time, this isn't the worst thing in the world. What this would be is it's doing 400 battles in a minute, which is still multiple battles per second. Like specifically, that's still 400 battles divided by 57 seconds, or we'll call it a even minute. That's still like almost 7 battles per second, which is fast. That's not bad, but it could be better. And at 7 battles per second, if we wanted to do 1 million battles, that'd be 1 million divided by 7 divided by 60 divided by 60. That's almost 2 days of running to do 1 million battles. But I feel like it could be faster. We just need to find how to make it faster. But anyways, I guess I'll just leave it running in the background. As long as it's like generally a complete success for 100%, that's probably good. Earlier I was running it on 1,000 at a time, and it was a complete success for 20%. So it basically was no better than this. And actually potentially even worse, because it could be biased against battles that take longer. Which if every battler is getting slowed down, then battles with lots of strong Pokemon where there's a lot of back and forth could be the ones that time out the most. So those battles could get disproportionately canceled. So this is probably the safest approach, even if it still times out occasionally. Oh, and occasionally it just takes way longer too. This is that timeout in action. If it has to time out, it does take significantly longer. But I'll just leave it running in the background, and I'll move on to one of the other problems that we need to tackle, which is double battling. So I'll close out of that. Nuzlocke run. Okay. So compared to last time, if we open up our Pokemon Black run, there is now more information in here. Since last time, I have added all of the trainers up to Gym 2. Yeah, like so the timeouts right now is just in this simulator. So it won't be a problem during the actual run, but it just means that the data to train our team building AI will take longer to train. Or it'll take longer to have the data set ready for that. Because we want the Elo of all of our sample battles to stabilize. So if we take a look at the ladder, the longer every simulated battle takes, the longer and longer this ladder will take to stabilize. So we generally want to have like a pretty strong idea of which team is better than what, so the model can learn to predict Elo based off of the team's makeup, which is the idea for the team building model. So that'll be running for a while. But as for the actual oh, I accidentally wiggled it and then all of my windows went away. Okay. So, anyways, I've added the trainers up to Gym 2, and I've also added 2 new columns to our run information, which is what kind of battle it is, whether it's a single battle or a double battle, and whether or not the battle is required. Previously, we just simplified things by forcing the AI to fight every single opponent. Yeah, so like the data is still being simulated. We got it running much faster now. It's going at about 7 battles per second to simulate like the millions of battles we want to simulate. But since it's still kind of slow, I'm just leaving that to run in the background. But now what we're doing is we're going to implement double battling when it needs to double battle, and probably a random roll on if it will fight optional trainers or not. So we have this big Excel spreadsheet, which is basically the run. This is all the information in one central place for like what the run of Pokemon Black will be. So this sheet is just all of the trainer information. So you can see like a single row will be like Pokemon Trainer Bianca with her Oshawott. Or if you are on the B route, then she'll have a Snivy or whatever. And the kind of route is based off of what starter you pick. So I've updated this spreadsheet to have all of the trainers up to Gym 2. Last time it was Gym 1. And that means now there are 2 double battle fights, which we need to add support for. And both of them are required, so we can't skip them. Our AI actually last time was able to beat up to the first gym, which is not really beating a Nuzlocke yet. But it did beat the first gym. And technically, if we ran millions of runs with just a random player, it'd probably win eventually. But we want something that'll win most of the time. So we're increasing the amount of difficulty by going up to Gym 2. And now there are some double battles, so we'll have to add support for that. And there are also items. There are TMs, and the way that the AI will be able to use TMs is it will enable moves that match that TM. So when it's team building, it will be able to add workup as a move to its Pokemon. It'll be able to add cut. And then for these like berries, it'll be able to give the berry to one of its Pokemon. Right now it's programmed to just go in with no items and it completely ignore items. But we want it to be able to take advantage of that. So the way it's kind of set up is we have this run spreadsheet, which is basically like what battle leads to what. So like at the start, you get this encounter and you have this level cap, so on and so forth. And our loop is going through each trainer, deciding whether or not it's going to battle it. And based off of the battle ID, it either unlocks something or it doesn't unlock something. So our simulated run will be off this spreadsheet. And once we get a model that is consistently winning in our simulated Nuzlocke, then we will actually pull up the game in an emulator and play the game using the AI to make all of our decisions. So for now, we want to improve the framework of doing the simulated runs. So that means double battles. So right now our build... let's go to Nuzlocke run. So this build teams function is building all of the enemy teams. This team build function is just picking a random 6 Pokemon from the up to 6 Pokemon from your box, setting their levels to the level cap. Setting their moves and using them. Yeah, so double battles work pretty much exactly the same way as a single battle. It's just that you've got 2 Pokemon out. So we'll have to add a new kind of template AI for now. Right now we were using this best move AI where it uses just the strongest move on an opponent. Now what we'll have to do is we'll have to add another one. This is just until we do the reinforcement learning, we want some sort of template to use. So this is going to be the best move double. And this will be best move double player. And I think the logic we'll do is it will pick the best move that hits whatever Pokemon. So if it can do the most to a different one. And actually, yes, you can select friendly Pokemon, which leaves us a lot of room for strategy. That maybe it would be a good idea. There are some moves that have good and bad effects. For example, the move Swagger will increase the target's attack stat by 2, but confuse them. So maybe the AI could learn to give its ally a item that cures confusion and then use Swagger on the ally. And so that would just sharply raise their attack, but then they would snap out of the confusion and they would just have higher attack. So yeah, there's a lot more room for strategy. It's why double battles are the common battle type for competitive Pokemon. There's a lot of cool things you can do by targeting all of that. So what we'll do is we will, I think, open up Pokémon first, the documentation. And we'll need to create a double battler. Unfortunately, right now, the double battle support is relatively limited in Pokémon, so hopefully it'll be good. Or like hopefully it'll be doable. Unfortunately, I'm not really seeing how to do a double battler. Oh, hey, thanks for stopping by again. Right now, so we've got the AI beating the first gym, so I've added trainers up to the second gym. But 2 of the required battles before you get to the second gym are double battles. So we need to have another, just for now, filler AI, so just this best move player that picks a double battle, or picks a move that will work in a double battle. Yeah, like, so it'll either, like, the reinforcement learning based method will probably have to be trained to, like, 2 different models. 1 model for single battle, 1 model for double battle. Just because, like, the strategies that go into both of them are so different, and rather than have something that can support both, it's probably better to just straight up create 2 models and do it that way. Otherwise, you're probably going to just kind of shoot yourself in the foot and have so much extra work for very little effort. But yeah, so hopefully we can figure this out. Maybe there's an example of a double battle. I haven't played around with double battles at all yet. So I want to see, hopefully we can find it. Because I don't want to just have to use random moves. You know what, like, let's do this. Let's create a random opponent. We're gonna say if name equals name. Import random player. It might be random player. So, yep, there we go. There's our random player. So we have a random player, which will be the opponent. I figured that's what you meant. But, yeah, so let's go to let it run. Here's our server config, because Pokemon Showdown is running locally. And then we pass in the server configuration, and the battle format is going to be Gen 8 random doubles, I think, is a format. Let's look at all the formats. I think there's a random doubles. Otherwise, we're going to have to specify the teams, and that's a little bit annoying. Random doubles battle. There we go. Gen 8 random doubles battle. So there's our opponent, and the player is going to be a best move double player with the same information. And then we're going to say player dot battle against opponent. We need to say async def main and put all of this stuff in there. And then lastly, we just copy paste some code from our other script. All right, so here's our code. It's going to battle just our player that we're trying to make right now that'll do double battles. And right now we're just trying to simply pick the best move on each of the opponents. But we need to see how this is going to work. And we're going to print out a lot of stuff to the screen so we can tell exactly what's going on. Like, is it running choose move twice? So when it runs choose move, is it just going to be for a single Pokemon? And we select the target, or what's it going to do? So what we'll say is we'll say print the type of opponent Poke to see what is it. Is it a tuple? Is it just going to be a list? Is it going to be just a single Pokemon? What's it going to be? And then we're going to just choose a random move. And also let's print. So let's do something like opponent us. And now let's run this. So this is going to be skipping over any sort of logic so we can see exactly what's going on. Oh, I have to open a new window because I'm using the other one. All right, let's simulate some double battles. Trainer AI / best move double dot high. Oops. Import async IO. Let's try that again. Still have a couple more things to copy paste. Forgot about that. There we go. Let's try that. We just want to do one battle. Okay, so this should start printing stuff once it loads. Okay, so they are lists. During a battle, it seems that both the current Pokemon and the opponent is a list. So it's not just showing us one Pokemon, it's showing us a lot. So let's print what are available moves. And actually, random move is choosing a random move. Let's see what choosing a random move actually even looks like. I just had PokeEnv open. Oh, it was right here. Player. Choose random doubles move. There we go. Let's print what random move is. And we no longer need to print what these types are. Okay. So we can see that the moves, choose random double moves, is, or battle.available moves is what's being printed first. It's a list of two lists. So it's a list of the available moves for your first Pokemon, and then it's a list of the available moves for your second Pokemon. So we need to like process them separately, and then go from there. Okay, so that's doable. So that means that it's just fairly simple. So what we'll say first is we'll just pick our first Pokemon what to do, and then our second Pokemon what to do. So we'll say for Poke1 moves in I guess we don't really need to do a loop. We'll just say Poke1 moves is equal to battle.available moves 0. Powers 1 and best move 1 is going to be this. So basically we are finding the best move for the first Pokemon. But how do we know what to target though? That's what confuses me, because it's saying choose move fly 1. Okay, so this fly object, we need to give it a target, I guess. There isn't a whole lot of documentation for the double battle since they're still working on it. But we have to select which target to hit. And it's not enough to just look at the opponent Poke. So this is going to be against, so target 1 powers is this, which is going to be battle dot opponent opponent active Pokemon 0. And then we'll say if battle.opponent active Pokemon if the length of that is greater than 1, then we'll say target 2 powers is equal to it on the other one. So best move target 1 is on the first target, and then we also have to repeat this on the second target if the second target exists. And then we'll say that the best move is equal to the max of best move 1 best move 2 to, or let's do this. Best move 1, best move 2, and we'll just do exactly what we've done before. Key equals lambda pair pair 1. So we're selecting the best move by power out of these two. And we'll say if, okay, you know what, it's probably just simpler to just do it in if statement. It's a lot more readable. If best move 1 is greater than best move 2 1, best move is equal to best move 1 0, target is equal to, we'll have to decipher, I guess target's probably equal to 1, because if you hit the other one, so target's probably equal to 1, else it's going to be best move 2, and our target's going to be 2. So this is a whole lot to just say who should we target and with what move. But how do we tell create order what to do? Oh, we can give it move target. Duh. So we'll create the order with the best move, and the move target will be target. Formatted move order. This still only seems to me like it's one move, though. Like it wouldn't be 2 moves. But let's try it. Move order is going to be this. Let's print move order and then return move order. So far we've just told what should be our move based off of the opponent Pokemon. But I think we've only selected one move, and that's not going to be enough. It'll run. Current Poke is not defined. Oh, oops. Current Poke is equal to battle dot active Pokemon 0. Because for now we're just looking at our first Pokemon, which I think this won't work. I think this will fail because we aren't giving 2 orders. We're only giving 1 order. Yeah. So that means we need to create multiple orders. Let's look at this battle order object to see if we can get some sort of hint as to what it is on our own. So let's go to the GitHub page. There's a lot of diving into the GitHub for this project. Okay, it's in player. Battle order. Double battle order. Okay, so there's a class called double battle order where you pass into battle orders. Okay. So that's not bad. So we'll do that. From Pokémon dot player dot battle order import double battle order. And then we just have to create a double battle order, which is 2 move orders. So this is going to be Poke1 move order. And then we'll say if battle.active Pokemon, if the length of this is greater than 1, then we'll basically just repeat the whole process. But choosing our second Pokemon and all of its available moves. And then we're going to say move order is going to be a double battle order consisting of Poke1 move order and Poke2 move order. Otherwise, our move order is just going to be Pokemon 1 move order. Alright. Let's try that out. If it doesn't error out and it works, then maybe we just did something that makes sense. I should probably have done save replay equals true. This is using a best move double player. Let's check out Showdown and see what's going on. There we go. Waiting for players. Okay, so it's probably not picking moves. Yeah, it was failing to pick moves, but we're not sure why. If we go back in here, this is certainly a double battle, and it's a random double battle, but it was failing to pick moves. Let's go to Pokémon again. There should be choose random double battle move. Alright, let's try this again. Also, I'm going to do save replay equals true. Yep. That way we can watch the battle back again if it happens very quickly. Something tells me that's not going to be a problem. Oh, max arg is an empty sequence. Okay, so this is improvement compared to last time. Because we actually got an error message. Max target 1 powers. Okay, so this means that our target 1 powers ended up being empty at some point in time. Which is weird. If target 1 powers, if the length of that is equal to 0, best move is equal to let's say none 0 or none -1. And here we'll say if the length of target 2 powers. Basically, we want a case where it's just it's never going to be the best. If it's negative, then it's impossible for a real move to be negative. Best move 2. So best move equals that. Otherwise, we're going to find the maximum. Otherwise, if there's no best moves, we're going to say there. And then we'll say if best move... Okay. If best move is none, then we need to just return a random doubles move.
Chord progressions, sounds, little ditties, tiny things.
And then we'll repeat this kind of idea up here too. Yeah. So clearly the battles get a lot more complicated once there are 4 Pokemon in the battlefield instead of 2, because no longer are you just trying to attack your opponent, you're trying to find which target to attack, and with who. Should you both attack? Should one attack and the other one not?
Or borrowing something that I heard.
Okay, so I think we've misinterpreted how the list will look. I think the list will always be there, but it will be a none. So what we need to do is we need to say something like, if battle.opponent Pokemon 1 is not none, and if battle.active Pokemon 1 is not none. Because it seems to always be a list of 2, but if the Pokemon's fainted, then it's just none.
Do a little changey thing and pretend, like it's yours.
Oh, I forgot to do it in one of the spots.
No one.
Alright, let's try that again.
It's theirs. Ooh, it's kind of controversial. Is it?
Obviously, chords and melodies, there's only so many different things you can do.
Yeah, you don't want to push it.
Okay, it's running, at least. Let's refresh.
Be subtle,
Waiting for players.
like a sneaky thief in the night.
And it's just sitting.
Make a little note saying thank you very much for what you've done.
I forgot to copy this none processing thing.
this and you start to pick up on the enormous amount of repetitive, you know.
All right, let's try running it again. It seems to be much slower, unfortunately.
The same artist all the time.
6 battles. Okay, it's running. Oh, it failed. But it was running. We got 7 turns into it. Before then it failed. Probably because it was on the last Pokemon. So it failed here.
If I do this, I'm
None type has no attribute damage multiplier. Okay. Okay. So I see what's going on here. It could be a none and then a Pokemon, or it could be a Pokemon and then a none. So it's not like slot 0 is always going to be a case. So we actually need to do something like this. Else we're going to say best move equals none by 1. Okay, I think this makes sense now. This definitely needs to be cleaned up. Yeah, like this is becoming a mess in here. Let's create some helper functions. Let's do something like def, you know what? No, screw it. I'm insistent. So I'm gonna say if battle dot active Pokemon 0 is not none. And I will tab all of this over. I will change the Poke1 moves into just Poke moves. And at the end it says Poke1 move order equals that. Else, Poke1 move order is going to be just nothing. Is going to be none. Then we copy this whole thing. Paste it here. The only things we have to change is this, and instead of checking 0, we're going to check 1. Then we're going to say if Poke1 move order is none and Poke2 move order is none. Then we're going to return a random doubles battle move, which this shouldn't happen. If just the first one is, then we're going to return just that second Pokemon's move. Otherwise, if the second one is none, then we're going to return that. And the last case is where we will return a double battle order, which has both Pokemon 1 move and Pokemon 2 move. Lots of stuff in there, but basically we're checking the first Pokemon if it exists, then checking what move should it use on each opponent if they exist, and repeating this kind of process. Waiting for players again. Well, let's see where it fails, if it fails. Maybe it's getting stuck somewhere. It was working up to this point. It sent out Wobbuffet and Melmetal. And Regigigas and Toxicroak. It used a move. It became paralyzed. It once again used a move. It's still going, it's just taking a little bit of time, I think because of the background processes that I'm running. Let me check that other window that I had before. It's still running, but maybe it's just interrupting the server a little bit. It just seems to be running, but a little bit slow. So it could just be because of the servers being hit so hard by some of the other scripts that are going on. Jeez. It is... Oh, and there we go. It made another move and then failed. Okay. The issue this time, best move 2, reference before assignment. It got almost to the end of the battle, but then it failed. Ah, I see the issue. I said best move 1, but then I had best move 1 here instead of best move 2. So it almost got there. Unfortunately, we're running a whole lot of simulations in the background. You know what, I'm going to go ahead and stop the simulations for now. It'll speed up the battle simulation so much faster. Oh, another error. I stopped the simulations in the background and now this should be super fast now. Okay, none type has no attribute damage multiplier. This means we're using a none somewhere when we shouldn't. It's here. This should have been a 0 and it was a 1. On the bright side, now that the simulations are not running in the background, these battles should be significantly faster. Illegal multi-byte sequence. Huh. Oh, it's when it was saving the replay. That's fine. I'll just get rid of the... No, it should be able to... Okay, so it seems like saving replays is broken for double battles right now. Which is a shame, because I want to be able to watch the video. So maybe in that case what we can do is at each time we'll sleep 1 second. We'll say asyncio.sleep 1. That way it'll be slowed down enough that we can just watch it live. Watch a battle. There we go. Also, right now it is not doing any Dynamaxing or anything, which could be leading to its demise a little bit. But it won the battle. I'm not sure how good it is, but it did win the battle. We can then run a little bit of a tournament to see how good is it in general. Instead of just battling it against a random player, we can battle it like one time. We can battle it many times. So we can do something like face off against the opponent 100 times. We'll get rid of that sleep, so it doesn't do that anymore. And instead, then we will check print best move double battler win ratio is going to be equal to player dot I believe it's n wins. Yeah, there we go. N1 battles. Divided by player.n completed battles. And this will tell us what the win ratio is for this player. And finished battles. And now it's no longer saving the replays because I think that's just bugged to double battles. Double battles, they've said, are still in development. So right now, the way that it's doing it is this best move player that we just wrote. It will look at the moves and it will try to find the best, or not best, but the most damaging move against which opponent and use that move. So if it knows a grass type move with high base power against water type Pokemon, it'll use that compared to a weak ice type move against a flying type opponent. So it'll try to find the best, most damaging move. Basically the most simple way to play where you're not taking into account anything like any sort of strategy or status affecting moves or stat boosting or anything. You just try to do the most damage. The opponent, on the other hand, is just doing randomness, because we want to see how much better than random is this picking best move approach. It's also just, the point of doing this is just so that we can see what this object looks like, and then we can start to swap out stuff. We're definitely going to need to simplify this by using some helper functions to get it to work better. I can't tell which battles are supposed to be going on. Because there seems to be battles running, but I don't see them. There we go. Found the battles that's going on. We can see the battles are going by pretty quickly. Oh, I know what the issue is. It's running only one at a time. Let's go to max concurrent battles. There we go. Let's say you can do 20 at a time. That'll make it tremendously faster. There we go. Now it's actually simulating all those battles at the same time. Lots of battles are getting started, but yeah, and then the battles are so, yeah, that's the issue. The battles are so fast that they are, they're not like loading whenever we click on them. Like they're on turn 4, 2 seconds later, they're on turn 5, waiting for players. There we go. Okay, so we can still download the replays directly, but it seems like the script to create the replays from Pokémon is bugged. So maybe we'll take a look at it later and we can try to help them. Okay, so the win ratio, 98%. So it makes sense. Just simply picking the most damaging move each time will, compared to just randomly picking, will win you battles 98% of the time. And they simulated 100 battles against each other. So that means it just lost 2 times. But our opponents won't be just randomly picking moves. Instead, they're going to be trying to pick the best move each time. So what we need to do is we need to make an even better player, which will be the game AI. So for single battles, we already have a game AI. So there's a tool called Pokemon Essentials, which is a toolkit for creating like fan-made Pokemon games. And it uses the game engine RPG Maker. So they took Pokemon and they ported it over to RPG Maker, and that includes the trainer AI. So what we've been doing is porting that from the like kind of Ruby code that's in RPG Maker and turning it into Python code. And it's in this Essentials AI folder. Basically, the way that it works, if we look at game AI, there we go. The way that it works is it will, for each of the available moves, it will calculate the score of that move based off of its effect. So if it's a move that will make the opponent fall asleep, then it will score it higher if the opponent isn't asleep, and it will score it negatively if the opponent is already asleep. Things like that. Or if it's like Protect, if the opponent has if you've just used Protect, then Protect is likely to fail the next time. So it'll decrease the score if you've used it again. We're just copying the exact same AI from this RPG Maker script. So we're not trying to improve it or make it any better. We want to be as faithful to that as possible because we're trying to mimic the AI that's in an actual game. And the AI can be dumb sometimes. It can be manipulated. It can just repeat the same dumb move. So we kind of want to mimic that. And so basically it'll just do this kind of basic approach of looking for every different kind of move effect. When should it use a move with that effect and when should it not? So this gives a score based off of the move effect. Then if all of the moves that it found have a score of 0, or the maximum score is 0, then it's going to kind of give up and pick a random move or switch. But after we've scored the effect, then we need to score it based off of the damage that it does. So what that means is we are going to... Yeah, so here's the move effect score. It starts out with a score of 100. Then it gets adjusted based off the move effect. There's a couple of other things that are still to-dos to make it more improved. But these are kind of minor edge cases. Like if the user's asleep, prefer moves that you can use while you're asleep. If the target is frozen, don't dethaw them. Things like that. And then after that, it's going to try to score the move based off of how much damage it'll do. So if it's a high damaging move that would like KO the opponent, then that gets scored higher. If it's a lower move, then it won't. Lastly, it gets adjusted based off the accuracy, which we need to improve this a little bit based off of like the opponent's evasion and your evasion, and if it like is a move that always hits, then that kind of thing. And lastly, it returns a score. We then pick the best move out of all of them. If the best move has a score of 0, then we just pick a random move or we try to switch. If the best, if there is a move with a score above 100, then we pick a random move weighted by score of those moves that are above 100. If it's less than 40, that means they're all bad moves. Then we'll try to switch. And lastly, if they're all kind of mediocre, we'll just pick a random move weighted by the score. And that's how the game AI works. We can take this and make it work for us in the double battles, but we'll have to clean this up a little bit so that it is an easier process, because basically we'll repeat this 4 times, because we're going to do it for user 1 to target 1, user 1 to target 2, user 2 to target 1, and user 2 to target 2. So this whole process we'll have to repeat multiple times. But once we do that, we can use exactly the same logic for the back-end processing. Okay, so that seems like a good thing to do next. And that'll give us our game AI double battle opponent. But for now, I'm going to go get something to drink, and I'll be right back in a couple of minutes. Alright, I am back. And my cat has come into the room. This is Theo. He is my cat. Alright, you can go now. He was scratching at the door wanting to be let in. He followed me back up whenever I got a drink. Alright. So, let's clean this up a little bit so that we can turn it into a competent double battler based off the game AI. So I'm going to create a new file, which is going to be game AI double. The calculate move score can work exactly the same way that it's worked before. All that we need to change is, man, I wish this was smarter, but oh well. Alright, all that needs to change is when we call it and what we do with the information. So for that, we're going to create a couple of helper functions. So we're going to do something like get move scores, user, target, we'll say battle, user, target, and I think that's it. I think that's all we need. And I guess user moves. Sure. Oh, we also need the move effect map. Okay, I think that's all we need. What we're gonna do is we're gonna say, we're gonna copy this. This calculates the move score for each of the options. And then we need to return the options. Then what we're going to do is we're going to say something like decide slot action or something like that, which will have battle use. It'll have exactly the same process. User, but we won't have target, and we will have move effect. The idea of decide slot action is that we will say something like options equals empty list, options plus equals get move scores, battle, user moves, user, if battle dot opponent active Pokemon 0 is not none. I'll do that. And lastly, we check if the other slot is available. So this is going to get all of our options. Our options for the first one, our options for the second one. But this is going to be move score 1 for move score in get move scores. And then similarly, this is going to be exactly the same idea. But instead of 1, it's going to be 2, because we're targeting different opponents. max score is then going to be the maximum over the options. But the action, the thing is going to be action 0, 1, which, because we have to dive into this move score object and pull out the score. So we're going to pick the maximum thing. So the target would be max score 1. The move would be max score 0, 0, and the score would be max score 0, 1. Alright, so we've extracted the information, and now we just have to decide what to do with it. Actually, we don't even need to extract this information yet. All we actually need to know is the max score. And this is where we do our if statements. So if the maximum score is greater than 100, then that's where we can decide our best move, because everything is good. So we're just going to return I guess I should put this whole thing inside the class so it can access that self function. Yep, there we go. So it's going to create an order where the target is equal to target. Which let's check that again, because I think it was move target. Yep, instead of target. So this is going to be options. So move score target for move score wait, why did I even do this? Just I guess it's fine. I guess that makes sense, whatever. The sum scores is then going to be x 0, 1. And then, so if we do that, then we're going to say best moves E to select the right one, 0, 0, with target being best moves E1. Okay, that makes sense. Okay, so there's our branch for if max score is greater than 100. Why is this? Oh, because there's an extra return. But now we need some of the other branches. Now we just repeat the same idea down here, but instead of best moves, it's options. This is again options, 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 options. Okay. And now this one, other options is equal to e switch poke, enumerate switches. Okay, so there's a little bit of added complexity because we need to add on more things to this. Because target is not just one thing. We need to do this calculate or get move scores. Other options plus equals get move scores, and we're gonna pass in all this stuff again, but we're gonna change up what we're passing in. Battle user moves is gonna be switch poke dot moves dot values. User is going to be switch poke. Get move scores. Do we need the target? Yeah. But we don't need to know which target it's going to hit because we're just deciding whether or not we are going to hit them at all. Battle.active. There we go. So we'll paste that there and paste this one here. And now we say if there are other options, it's the max of not x2. Oh, I guess I do need to keep track of which Pokemon to switch to. Right. It's going to be switch poke, or it's going to be move score switch poke for move score and get move scores. There we go. That's the right chain of events. And this is just Pokemon 1. Oh, I think it's switch poke move score. Yeah, because we're maximizing over the score. So if it's greater than our max score, then we're gonna switch to that switch Pokemon. Otherwise, if it's just greater than 0, then we're just gonna switch, or we're gonna use our only move, our best move, which is gonna be options move 1, or move 0 1 0 0. This is just our only shot. Otherwise, we're just gonna choose a random move. Yep, and again, that's just going to choose a random move. Okay, so then this decide slot action is complete. So we've got it to the point where now a single user, or single Pokemon, will decide what to do. We just have to run this function twice on the two different slots, if you have those two different slots. So we can delete all of this stuff. And we'll say that if battle.active Pokemon 0 is not none, Poke1 action is going to be equal to decide slot action, but we're going to pass in battle.active Pokemon 1 and battle.available moves 0 as well. Else, we're going to say that Pokemon action is none, because this means you don't have a Pokemon in your first slot. Then we just copy paste to get our second Pokemon's action, and we just change all of these zeros to a 1. And now we need to decide what to do based off of these things. So if Pokemon action is none and Poke2 action is none, which shouldn't be the case, we're just going to return self.random create random doubles move, because this is the hopeless case where we're seeing there's nothing to do because there's no Pokemon to use, so we're just going to do something random because maybe it's broken. Otherwise, if it's just Pokemon action that's none, we're going to return just Poke2 action, because we don't need to make a move for our first Pokemon if it doesn't exist. On the other hand, if it's just Poke2 action that's none, we'll do that. And the final case is to create this like double battle order, which will combine both of their actions into one. The only thing we need to do is copy all this stuff into the game AI double battle. And let's go ahead and copy our test code as well into the bottom so we can test our game AI. So instead of best move double player, we're going to do game AI double player. And this is going to be game AI double player. We'll see what its win ratio is. Let's just try it. It's bound to have some issues when we first run it, but that's to be expected. So let's say game AI double. Yep, and attempted relative import. No. Okay, let's move this code then, because I don't want to change how this stuff works. Or what the heck, I'll just remove that dot. I can add it again later if I really need to. Okay, decide slot action is not defined. That should be simple. Decide slot action, it's right here. Oh, but I need to do self. And I need to take self as a argument here. All right, let's run that again. List has no attribute ID. Okay, let's see where it first failed. Okay, so it seems like we're passing in a list of lists or something for the user moves. Calculate move score. Yeah, because it's trying to get the effect, but it's being a list instead. Maybe it's no, that wouldn't be the case. Let's look. Battle.available moves 0. This should just be a list of moves, which is right. And then get move scores. This should be a list of moves of that available Pokemon. Let's see, does it give us a line number? In line 70. So it's in this. Oh, but we want one level above. 93. Okay, so it's in this one. It's saying user moves is like a list of lists. Oh, wait, no. There. Fix it. I forgot to replace the user moves. Because we're not using the battle.available moves, we're using a list. Alright. Move effect requiring... Oh! I also know this issue. Move effect. We need to pass in the battle, because then it's going to run the battle, get move effect score, now uses battle, game AI. This needs to pass in the battle, calculate move score, needs to also accept the battle, and then get move effect score also needs to take in the battle. Which means our single player AI will also be broken until I fix that. It's because we added the battle object. Okay. Pokémon move order is not defined. Oh, because we called them Poké1 action and Poké2 action instead of move order. Okay. Let's see, there's another error. Max arg is an empty sequence. Ah, okay, so the options is empty. In 101, line 101. Okay, so when we have no options, so if the length of options is equal to 0, we're just going to go ahead and return a random doubles move. Yeah, we'll just choose we'll just return a random move. Or actually, wait, no, we should say max score equals 0. There we go. List attribute has no attribute moves. Okay, we're getting closer. That's a different error message. List object has no attribute moves. Switch poke.moves.values. Okay, so it's saying that Switch Poke is a list and not a Pokemon object like we're expecting. Which is weird, because available switches, I would think, would be a list. So then each item inside of it. So let's do something like print the type of Switch Poke. Or we'll just print Switch Poke directly. And we're going to change it so that instead of doing 20 battles at once, they're just going to do one battle at once. So it doesn't flood our command prompt with so much information. Because that's making it kind of hard to debug. It should print out what Switch Poke is now. Okay, there we go. Okay, so it's a list of Pokemon. Yeah, Switch Poke is being a list of Pokemon. So I think what we need to do is we need to index one level deeper. Which we're doing the Switch Poke thing here. Let's pass in user slot as well. And this is going to be 0. This is going to be 1. That way here we can say something like available switches user slot. I think that's what's going on. List indices must be integers or slices, not Gen 8 Pokemon. Simple. We just get rid of that. One more run through. I think we're almost there. List attribute has no attribute status. So this is another instance where we're passing in a list instead of the actual item or the actual Pokemon. — 493. Let's check move effect 493. This is all of the move effects that the game AI has. And actually, this isn't even all of them. This is like not even a third of the move effects. I've been manually rewriting the Ruby script into this format for a while. So let's see, what line of code did it say it failed on? 493. Okay, so this is going through available switches plus the user. Oh, okay. That's kind of annoying. So let's do this. Let's say if type or if is instance battle. If it's a double battle, switches is equal to battle dot available switches 0, else switches is equal to battle dot available switches. Hopefully that's enough. It's running. It's taking a little bit to run. Let's see if we can watch it. Game AI. Double play. Yeah. Okay, yeah, so it seems to be running. So I'm going to bump it back up so that it can run a lot of battles at the same time. Because right now it's only allowing itself to run one battle at once. But we want it to be able to run 20 battles at once. Oop, double battle's not defined. Oops. I figured that would be the case. We actually need to import double battle into move effect so it knows what a double battle is. From pokeenv dot environment dot double battle import double battle. And now we want to see how does the game AI do against random battle, which the game AI should defeat random battle no problem. Though actually the game AI right now is not Dynamaxing at all because the it's not implemented to try to Dynamax. So that is something that would help, especially in these like Gen 8 battles where Dynamaxing is kind of a big thing, and can like turn the tides of a battle. So that's why it could actually be somewhat close in these, and it's actually why it's so impressive that the simple best damaging move did so well, because it did well despite the fact that it was not even able to Dynamax. So in the most recent games, which is Sword and Shield, there's a mechanic, very creative mechanic, where you can, once per battle, have one of your Pokemon get really, really massive. It's called Dynamaxing, where basically the Pokemon's HP grows by a certain amount. All of its moves do a ton more damage, and they change, they affect everybody. And it only lasts for 3 turns. And it's something you can only do once per battle. Whenever you're Dynamaxed, your moves will even hit through Protect. So you can't protect against things. It won't do full damage, but it'll still do some damage. And things like that. But with this Pokemon environment, you have to tell it when you want to Dynamax. It's not the most creative mechanic, I don't think. But it is the most recent thing. Unfortunately, sometimes it's a little bit hard to tell when it's just waiting or when it's stuck, because there's this critical unexpected error message thing, and I'm wondering if it's just stuck permanently because of these critical unexpected error messages, or if it's just slow. Because I think it might just be stuck. And I think what's going on is it's like the way that we have coded the switching in the game AI, it doesn't remove the switch from the other one. So I think what we need to do is something like oh, this is gonna break at some point too. This has just never been called. Oh, oops. I was editing the wrong one. What's going on is, like, whenever it's saying to switch, it finds the best Pokemon to switch, but if both of them need to switch, they're both going to pick that same Pokemon to try to switch to. And they can't both switch to that Pokemon. So I think what we need to do is here, we can say something like pass in Poke 2 action. Here's what we'll do. We'll say if this isn't the best approach by any means, but if is instance Poke 1 action, or actually no, we'll just say if Poke 1 action is Poke 2 action.
Alright, let's bring that back.
We're gonna return a random move instead of doing both of them switching. That's not ideal. Ideally, we would just want to pick like the next best thing to use instead of both switching. But generally, if they're switching, it's because they're kind of out of options. So picking a random move shouldn't hamper the performance like as much. Oh, it finally ran into minimize not existing. I knew it. I've been expecting that for a long time, but I've never actually encountered it. It's because minimize doesn't exist in the environment. I raised the issue on GitHub. I guess I should just do this. The minimize effect doesn't exist, so that's going to throw an error. Hopefully they add minimize, and in a new version of Pokemon M, I'll just pull it and it'll work. But right now, minimize doesn't exist. Okay, warnings are okay, but what isn't okay is critical failures. Are they back to doing 20 at once? Yes. The game AI does, like, our game AI is programmed and it actually will go slower than some of the others. One, because it's more complicated, but two, it's actually using a damage calculator API in order to calculate how much damage it's going to do. Oh, the critical issues is still running, which I think will make it fail. Come on, really? Oh. Dang it. I think I know what's going on. Let's try that again. I think is like full equality, where it's like exactly the same object, and equals is just they have the same value. So I think we have to just do like equals equality. Warnings are okay. But what isn't okay is critical. But for now, it seems to be working. And we can see the battles. Still no critical errors, so I think that last fix worked. Yeah, see, this enemy Pokemon Dynamaxed, which is why it says Dynamaxed right here. And it's, basically it's just all of its moved powered up, and it just does more damage, and it has much more health, and it'll turn back to normal after 3 turns. Uh-oh, waiting for players. That's never a good sign. Still okay, or is it just stalling a little bit? There's some warnings, but there's no critical errors, so I think it should still be working. Yeah, it seems all the battles have stalled. I'm not sure what's causing the stall. Let's check Task Manager just to see if it's still running. Task Manager has been taking a considerably long time to run, which is really concerning. It's eating up so much memory. My Docker containers. Which I guess makes sense. I have some extra Docker containers compared to normal running. Yeah, it seems to just be stuck. It's not doing anything. I can't tell if there's any battle that it's still making moves on. Alright, where did it fail? In the interrupt. And waiting for calculated damage. In that case, I'm going to run less at the same time, and maybe that helps. Because I think right now the my other damage calculation APIs are getting overloaded. Okay, it's running again. And skipping to the end, it at 1. Waiting for players. Oh, nope, it worked that time. Yeah, so the game AI, it relies on some other APIs that are running in Docker containers on my machine. So it could be a little bit difficult sometimes to run it very parallel without playing around with the same kind of issues. But it seems so far that the game AI is just completely crushing random player. It still is running into some issues starting up battles, but we're just getting warnings. We haven't got any critical errors yet. But battles are starting to slow down now. Yeah, I don't know what's causing this slowdown. Like, it's weird to me that it would be working sometimes and then just going to a complete crawl other times. It's still getting some messages though, so I think it's just slowed down and that it's not completely broken. Because the fact that there's still some messages scrolling by means that it's doing something. Yeah, there, it just switched some opponents. So I think it's just being really slow. Something has happened to make it unstable. Oh well, we'll let it set. And what we're looking for is similar performance against random as the best move player. And then we'll pit the game AI against best move player and see does the game AI beat the best move player. Which on single battles, they're about evenly matched, which makes sense because the game AI player isn't actually even done yet. So all of that extra information about move effects isn't done. Once that's been added, then maybe it will be better. But that's just a long process. Thousands and thousands of lines of code long. Just wait for it to come together and... What is the timeout? I wonder if that's part of the issue. Part of the game AI, it's calculating the damage that a move will do. Did I set like a really high timeout or something? No, I didn't set a really high timeout. But it does try 3 times. Maybe the timeout by default is like 13 seconds or something. Or like 15 seconds or something. And then that leads to it like trying again and again very slowly. I wonder what the default timeout is. I'll leave this up because it's interesting. What is the default timeout? Requests do not time out unless a timeout value is set. So maybe we would want to set a timeout to like 5 seconds or something. But for now, if it's just that is the issue, then we can bear with it. How many battles has it gotten through? There's only 33 battles remaining. I think it's almost done. It's still on this last bit of timing out, though. Some of the battles are almost done. Just waiting for them to finish. So come on, hurry up and finish. That way we can see what the final outcome is. How much better than random is it? Which I would be surprised if it's not 98% better than random. I'm impatient. I'm running it again with the timeouts. Because I think that will help tremendously in improving the speed. Oh, I know it could be a big time delay in that. Requests is blocking in terms of CPU. So we should use an asynchronous requests library. What I mean by that is whenever we do, like, we're doing things in an async way. So it will send, oh, I can, while I'm talking, I'll leave this up because it's more interesting. When it does a request to the Docker image, it's sending an API request over the internet, which is just my local internet. But since we're not using an asynchronous function to do that, the whole wait time is considered work time for the CPU. So it doesn't go and do anything else, which means it's blocking all the other things that could be running during that time. So what we need to do is we need to find a library that will do asynchronous web requests instead of the current blocking synchronous ones. I think that'll improve the performance of the game AI a lot because I think that is what's causing a lot of the issue. Because right now with this like timeout of 5 seconds, that means that the CPU is just going to be idle for 5 seconds while it waits to get a response. So is there requests async? HTTPX seems to be the way to go. It could be better. I think we've diagnosed some of the issues with the game AI. We're working on getting the double battling working now. The simulation has sped up a decent amount. I've got it paused for now while we're working on getting the double battling working. And I think I know what's going wrong with the game AI, in that it's taking a long time to finish battles. And it's because the timeout is blocking other things on the same thread from running. So what we could do is we can... I don't want to do anything here. But like basically for the game AI, it will use this library called requests to get the damage calculation. But requests is considered a like work task to the thread because it's not an asynchronous task. Everything that's not asynchronous is considered work. So that means it's going to, whenever we're running this, it will just wait the full 5 seconds and prevent anything else from running. So we need to swap it out for a library that will be instead asynchronous, which I think this HDPX is a library that can do async, because it claims to have asynchronous APIs. I could also just do better load balancing as well. Okay, so let's say import HTTPX. I'll leave the code running in the background while we figure out this HTTPX. Async support is what we need. And then what we'll do is we'll say try client.get, and then let's check the other functions just to see how do we do this. So client.get is going to I just want to do quick start. Okay, get post. So it's a GET request, but we need to attach JSON information. That's parameters. We don't want params. We want to pass JSON. Can we maybe just do data equals? Timeouts. Okay, yeah, there's timeout. And then we want the JSON stuff out of the output. So JSON response content is just .json. So it works basically identically to requests, which is nice. But is this an async function? This is not an asynchronous function. That's a little bit annoying. Because this is not an asynchronous function ordinarily. When's the last logged thing? 23:18. Okay, so it's still making progress. But that last one, it took 5 minutes before it made any progress. Shoot, this is not an asynchronous function. Which means it's annoying. It's annoying to call an asynchronous function from within a non-asynchronous function. Alright, I'm gonna copy this. Control Z everything. And then paste it as a comment. So that it's something to try in the future. But really, it's just getting stuck. Oh, slip. And it's like taking like 5 minutes. I think a better thing to do right now is just to shuffle the orders. To do load balancing by random shuffling. Basically, I'm just going to shuffle the URLs into a random order and then use them in that way. And the timeout is going to be 1 second. So if the damage calculator doesn't give me results within 1 second, it's just going to run that way. Rather than potentially taking all the way up to 30 seconds to run. And hopefully with the more load balanced nature of randomly shuffling these, they shouldn't need to take nearly as long to begin with. It's taking a while to get started. There we go. Let's look at the logs. It's making moves. We skip to the end, and it's, yep, they're still going along. Okay, so it seems to be faster now. But it's still getting stuck sometimes, making moves. But that was much faster getting it to make a move again. Also, I've noticed something. The completely random player in double battles will attack its own teammate just as often as attacking an opponent. So perhaps beating random 98% of the time is not nearly as impressive as it may initially sound, because they're also fighting against themselves. But on the bright side, other than it not being very efficient, the game AI seems to be working at least. Like, it's not done yet, but that's just because there needs to be more time spent making all of the other effects. Yeah, there it just used Super Fang on Kingdra. It attacked its own ally. We can skip to the end. That battle is done. Watch a different battle. This battle is waiting for players. Let's see. It's giving updates fairly frequently. Or it's giving warnings fairly frequently. So I think the timeout was a big part of it. Because an important thing to remember with async stuff is that this is all running on one thread. So it's not just one timeout it's doing. It's doing actually potentially several timeouts back to back. And if each timeout is 5 seconds and it's running like 10 battles consecutively or concurrently, it could be timing out for like a minute. And that's just for one move, let alone all of the many moves it's actually calculating. Because we're having it calculate for every possible move the Pokemon could make against target 1, for every possible move it can make against target 2, and then if none of those are good, it then calculates every single possible move all of the switches could use against either target. So at any one time, it's calculating 8, 32, so like 40, 80 moves or so. It's calculating like 80 damage calcs on each turn, and that's being just spammed to the damage calculator API, which I think is why it's so slow for some of the requests. Like if it gets overloaded, then that timeout ends up taking a long time to run. Okay. Anticlimactic, but we skip to the end just to keep seeing new battles. Here's another one where it's waiting for players. But let's see how long it takes for them to get playing on this battle. There's still no critical issues, there's just like some warnings. As long as there's no critical issues, we should be good. But it still is taking some time. There might be other battles that are going on. Oh, right. That's another thing about it being asynchronous. I didn't realize this. I just hinted at it, but the main problem is actually that if the timeout is fairly large, because of the fact that it has to do 80 odd calls to the API, it has to do those 80 in a row for one battle before it can move on to its next task, which is a different battle. Because it's, at the end of the day, single-threaded. It's just one worker that's working on many things at once. But while things are loading, in theory, it can work on other things. But our requests aren't asynchronous. So for all those timeouts, it's just sitting there doing nothing when it could be sending other requests to get other moves. So I think that's a big part of what's going on. Is there any battle that isn't just stalled? It seems like all the battles are stalled while it's waiting. Yeah, the last one is at 07, so it hasn't even given an error message in 5 minutes. I think it's just getting stuck. This is from a previous session. I think that's what's going on. Is that like 80 consecutive requests ends up just taking forever. Okay, so now we definitely know that that needs to be fixed. So let's fix that. We need to be able to call it in an asynchronous way. But how do we do that smart? So I guess this should be an async function. Score calculated damage. That's what we should do, is we should have this be a this should be an asynchronous function, and then we put the worry of making it async or calling it from an asynchronous way somewhere else, which will be in the game AI double. It tries to up here score the calculated damage. What we need to do is we need to import we already have async IO here. what we need to do is score is equal to asyncio dot get event loop dot run until complete score calculated damage. Oh, and then in score moves, we need to change one more thing, which is that these response things need to be await. All right, let's pip install HTTP X.
And so in creating, even with limited resources, I like
And let's
realize there's a lot of false image record.
import HTTPX. Let's try it. Now there's going to be more code issues, inevitably, but oh, this event loop is already running.
Refer to so-and-so upcoming producer is hitting the charts or is on the scene. They're written all the same way. And I see the same thing for these music sample packs. They're saying, these are the drums you need for your chart hits, yo.
Cannot run the event loop while another loop is running. Cool.
And your consumer is not problematic in itself.
Asynchronous code in Python is not the most fun experience when you're trying to do cool things. There we go. Finally managed to quit out of it. I thought there was something that we just saw earlier about running asynchronous code at the same time. Python async IO add to current event loop.
To realize to not be boxed into a scene. You may see yourself making music in a given genre, but then you have an accidental hit on YouTube. They step out there and then they're like, wow, I didn't know that, and then they'll shift towards that. Which of course
Okay, so I can just do asyncio.create task.
to realize that who you are, what you may succeed at, what people may love most about you, may be very, very different than how you see yourself.
Alright, let's try this. Okay, get gotten. Okay, alright, but it's working actually. Get got an unexpected keyword argument JSON. I think that's because it was expecting double instead. But it's not an async error. That's a something else error, which is good. Because I think this is supposed to be data instead of payload. Unsupported operand type for multiply, task and float, in score and move accuracy. This isn't awaited. That's the issue. Ensure future isn't awaited. Why though? Because I am awaiting the stuff deeper in the function. I'm awaiting it in, here we go. I can close out of this one. Request. Yeah. Await client.get. So what is this error message again? It's saying that, okay. asyncio.task and float. Shoot. I'm just not sure how to, like, without making every single thing async, which I can't make every single thing async. How do I call this? Because I'm doing like multiple layers of asynchronous functions, which is where the actual difficulty is coming in. Everything that I need to look at is right here. There's this await. And then up here, let's just shrink this payload so it's not in the way. And shrink this stuff, shrink this stuff. Still doesn't close the whole function. It's annoying that that doesn't do that. That's inconvenient. I need to like pass it the loop somehow so I can add it to the loop. There was like a library that I installed just earlier that claimed to do something like this. I'm gonna open up the Jupyter Notebook again and see if that helps. Maybe I still have it in the Jupyter Notebook. Nest async IO. That was what it was. Okay, so the idea behind this library is that it will allow you to add things to the event loop without getting that error message that's like it's already running. You can't do that. So we'll say run until complete that. So hopefully this will solve that issue that we were just bringing up, which is that you can't, no, that's not what I wanted. Which the issue is that you can't run a brand new asynchronous stuff thing from inside of an already existing one. But supposedly this fixes that. Built-in function or method object has no attribute run until complete. Oh. Forgot the parentheses. That's a simple issue. Oop. Get got an unexpected keyword argument data. Okay, wait. That's not an asynchronous issue anymore. So we got back to this again. It's not an asynchronous issue. That's great. That's just an issue with HTTPX. Get with body JSON. I need to make a GET request, but I need JSON in the body of the GET request because it's dumb and it needs that formatting. But it specifically does have to be a GET request. I just want to go and see what parameters get can take. So let's go to the code on GitHub. Client get subject get there should be a function called get. Let's say def get. There we go. Really? So we might have to say .request and then specify a get, but then pass in data or pass in JSON. So let's try that. Maybe that'll be what fixes it. So let's pass in get. JSON request. So the format for request is a method and then the URL. So the method is going to be get, and then we pass in this JSON. We can try that and see if that does it. I've never used this library before. It is a little bit different from requests, which is the library I'm typically used to. Oh, division by 0. Oh, that's a different error. Division by 0, that's great. Because that's a completely different error. Damage score is equal to sum of D divided by max health for D in damage. And division by 0 is because an attack is expected to do 0 damage. Okay, so damage score, this is in score moves, line 249. Wait, hang on. This is supposed to be their original current HP times the current HP fraction. So this should never be 0. I don't know why this is 0. I'm just going to go ahead and add +1 to it. So it's never divisible by, so it's never dividing 0. Okay, it's working, and it's doing async work inside of the battler. Waiting for players. Okay, but it's working. And the battles seem to be relatively quick. Waiting for players. Yeah, the battles are going pretty smoothly. I think that was the key, was adding async support inside of these kind of GET requests. There's still some slowness, but let's watch it and see if it gets back up. Yep, and it's back to running again. Yeah, and now the battle finished. So there was just a little bit of a chug, and then it zoomed past and finished. Waiting for players. The opponent has all 6 of their Pokemon. It's just waiting for players. And then, boom, like in a split second, those Pokemon are gone. It did a bunch more moves. Waiting for players. We're on turn 16. Skip to end, and it passed 4 turns in like 2 seconds. So when it's going fast and there's no wait, it can do several turns in a single second. Like here, the opponent has all of their Pokemon. It's turn 1, nothing has happened. Waiting for players. It's just hanging. There's not been any work done because it's just pending. But as soon as it actually finally gets to start, it'll go by much faster until it gets stuck again. And so resolving those times it gets stuck is where we're getting a lot of the speed improvement. If it'll ever stop. That's a little bit concerning. Let's see, is it? It's also stuck in here. Oh, I thought we had it But it still seems to be just getting stuck. Oh, wait. It said waiting for players, but then it switched to doing something. Oh, maybe I missaw. I wish I could see what it gets stuck on. But I can't see what it gets stuck on. Which is really annoying. Oh, it made a move though. It just updated stuff. So it got stuck for a little bit and now it's going again. And then that battle finished instantaneously. So yeah, it just keeps getting stuck somewhere and then the requests hang for a while and then they go through and it's super fast. So this could be a little bit of a balancing act of figuring out exactly like the right amount of concurrent battles to run, try to do some multi-threading to get it smooth sailing. Come on, it was doing so well. Pulling up Task Manager to see if we can see what's going on. No, like nothing unexpected is really hitting the resources that much. So it's hard to diagnose because it's not like I'm like running out of resources. The things that are hitting the resources the most is just the stream. This battle has been stuck here for a long time. Well, will it ever finish? That's the question. There should be 10 battles going on. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the 10th battle. No progress is being made here. Nothing here. I keep clicking on the same one. Yeah, and it's hung for 3.5 minutes doing nothing. So, like, at a certain point, it just ends up failing completely. Getting stuck forever. Yeah, this is just it getting stuck. Well, one thing that we could do is we could set the timeout to much smaller, like 10 times faster. And if we start getting issues about it completely failing every single timeout, then at least we know where it's failing. So one more time. Hopefully this works. If it doesn't, then I'll probably be done for the day. If it does, then I'll probably still be done for the day. But let's just see if with just the tiniest of timeouts and switching servers, if that'll be the way to go. Yeah, so some of these battles, just like before, the battles at the beginning were running really fast once they get started. Yeah, probably. I mean, it's almost midnight here, so I'm gonna be finishing up anyways. But I'm just hoping I can get this working before I go to bed. Yeah, I just don't understand why they're getting stuck. There's not anywhere else I'm doing a HTTP request or anything slow. But it just keeps getting stuck. Here, let's pull up Docker. So one of the damage calc things has some CPU usage. It's at like it's only running on one core, but it's like maxed out. So that could be the problem. So like I have a 48 thread CPU. So approximately 100% CPU usage for one core is 2% CPU usage. And this is going to be an approximation anyways of the CPU usage. So if that's the case, if the CPU usage is just pinned at 100% on my damage calc setup, then I think that just means I need more replication for my damage calculators. Yeah, like I think it's that they're waiting for the response, like what you're saying. Because basically I have 3 damage calc containers up and running, which are handling responses to this API. And I assumed that would be enough. But if they're pinned at using up their whole core that they're being given, which I think they're probably being given like one core, so it'll be like anywhere from 2 to 4% usage, then that just means I need more damage calc things. Which, I mean, I guess that makes sense. Like, I can try that. I can try spinning up multiple more and see if that helps anything. Let's see, what are the ports of my other ones? 8193, 8194, 8195. So I'll do 8196. I'll do 8197. And I'll do 8198. So I've spun up 3 more damage calculators. So let's see if that's the final thing I'm going to do for the night. I'm going to go here. I'm just going to say URLs. Yeah, that would be reasonable to do, especially if I were setting this all up in some like big Docker Compose. It would be worthwhile to set up some sort of monitoring thing so I can see the performance of everything. Since everything's in such a low dev environment, I haven't really set up a lot of those tools, but maybe that would be worth it if I'm connecting a bunch of containers, if I really want to do some serious optimization. Alright, so now I've got the URLs. And then I'm just going to say pick a random 3 URLs and try them out. If you fail in all 3 in a row, then it should fail entirely. Let's see if that works. Like, in theory, now there are twice as many API endpoints for them to run on. And we can see this one immediately gets CPU usage. Let's see what the overall Docker CPU usage is like. Oh, it's not going to show up under Docker. It's going to show up in individual things. But my CPU usage is still low. Maybe I can find those Docker processes and see what their CPU usage is like. Yeah, I don't know how much these stats can be believed, because like it jumped as high as 7% and that doesn't make sense. Waiting for players. It's just sitting and waiting again. I don't know what it's waiting for, but it's waiting for something. Well, I think for the night, that's it for today's stream. I'll be back in like... Oh, it just made some more moves, but I think in the end it's still just going to be stuttering and stuck in different places. Yeah, like, I'll see about... Like, I'll look up in my own time some things tomorrow about network monitoring and seeing if we can just figure out where the problems are happening. And I'll leave this running overnight just to see if it's something like it just never ends up finishing, or if it just takes a long time to run. Because it could just be that it could actually be that it's finding somewhere and getting stuck there permanently, like due to some error that's hidden. But yeah, so I'll leave this on, and I think that's it. So thanks for watching. I'll be back again Thursday to continue on this project and hopefully get like the items developed. I'll probably start next time by doing the items, so then we can get up to Gym 2, even if this is difficult. Because the only issue is that it's not efficient. But that's not the end of the world. Yep, thanks for watching. Bye everyone.